Okay, I'm back and I got it working. So let's start the model here. We see our ants start running around as fast as I can get them going. And when they find food, last time we had some strange things of just a small trail being created. Now we're seeing them pick up food, leave pheromone, and that pheromone is spreading out. So what was happening last time? When I was doing this editing, let's see where we are here. When I was editing back in these agents, somehow I had copy and pasted and done something. I remember doing something really quickly and strange things happening. I accidentally deleted the advance method where it said, cool, I'm going to step and set things up for my next amount, but things never changed for the self amount, and so the things were not being spread. All of the great work that we did, I had destroyed by deleting this method. And I can show that to you in terms of what's happening here. If we start the model again, and when it picked something up, great, see, I can see the pheromone trail being left, but no diffusion was happening. That's sort of where we left things last time. Now we are seeing that diffusion happening here over and over again. Good. Okay, let's do some final pieces. As we notice here, we are running this model, and the ants are not moving so much. Once they find their gradient, they are following that gradient really well, almost too well. I would like them to incorporate a bit of randomness as they are trying to wander around that gradient. Oh, I still have the one with it gone. Yes, okay, save that back in there. Let's try this again. Start as fast as we can get it. And let's go eat some food of that closest ant pile. Come on, ants. Let me just make sure I have the right version here. Yes. Okay. There is the pheromone getting spread out. Now, these ants, they love that pheromone and they go to that middle of the trail. But they're staying here, which had the most pheromone. They are not just randomly wiggling around and trying to find stuff. So let's try to get them to wiggle a little bit. Where can we do that in our ant code? I can say, well, if I am trying to follow the gradient, maybe I should be flipping a coin. Maybe I should be trying to randomly move around. If self.random.random is less than self.model dot maybe some probability of randomness, then I am going to make a random move otherwise I am going to follow the gradient. So just a little bit of tweaking here. So I'm going to need some parameter out there for my randomness. I am probably also going to need a parameter here, self.model dot, let's call that the drop rate. Okay, two different pieces are going to break my model right now because they don't exist. Let's go back out to model. We have lower bound. We are going to have those two pieces that I need, probability of making random moves and the drop rate. Prob random equals something small, and then drop rate equals what, 0.9 is what we had it in there. Okay, save those. Oh, Mesa. Okay, save them. Self.prob random equals prob random self dot drop rate equals drop rate. Now our model knows about those two numbers and is able to use them. We can finally do that save and try to get things running again. Let's see if they do a better job on the gradient doing a bit of wiggling when they're trying to follow it. Are they always on the gradient, or is there a little bit of movement back and forth? There's a little bit of movement. This is good. That gives them a chance of getting back out there and finding it. We also need to tweak these numbers over here to try to find good amounts. And it'd be nice to tweak those numbers that we just put in. So, again, to do so, we have to go talk to the server. The server is the one that is going to be setting things up. And we now have two new parameters that we want to be dropping in there. So prob random and drop rate. Great. Random move probability, and we'll just call this one drop rate. It would be nice to have these numbers make sense instead of just a copy and paste. And so drop rate, we are going to say 0.9, and let's start that off 0.1 up to 1 of increments of 1/10, and then the random move probability, we're going to have that be, say, 0.1, started off at 0.0 all the way up to 1.0, and 0.01. Give it a fine granularity there. Okay, let's see what this does for us. Yes, things were broken. Did I miss a comma somewhere? I did. I missed a comma right here because I added in new things. It was not happy with me. Okay. So run the server. Hey, look at these sliders over here. Yes, let's make them wiggle a little bit more and make it so they are dropping less as they go. Things should diffuse maybe a little bit less. Get a nice evaporation rate in there. See how fast we can get this to work. Grab some food. See what happens. Oh, look at that. They are wiggling enough that they are going back up there and eating all that food. They got down to 35 really quickly. And they sort of got everybody into their pool. But now they're kind of stuck in the middle. This is not evaporating fast enough. If it evaporated faster, then they would find things and then maybe forget about them, and they wouldn't be stuck in the middle. Or maybe the random move probability needs to be greater. So they follow the gradient sometimes, but not all the times. Maybe that would help them get out of this well of pheromone. So as it dissipates and it goes away, it's going to go faster here. Right here, there should be a little explosion of ants, where as soon as the pheromone all gets down to that lower bound, they are going to stop being here, and then the random exploration starts again. Poof, somebody finds the food, and then the pheromone trail starts again. Everybody's heading home. All the food is gone. Okay, we have a working version of the ant simulation building off of the chemical diffusion here in Mesa for us. And so this is where we're going to stop this chain of videos. That is a great conclusion to explain how ants are working in our world.